Hi, today is 1st July 2020 and from today exactly 149 days are remaining for CAT 2020. And today we are going to discuss from number system. Now there are four questions which I am going to discuss here. So basically there are two questions. Okay, why two questions? I'll say. If you look at question number 6, it says the number of choices of a prime number p such that p plus 10 and p plus 14. So which means p plus 10, p4 plus 14 all are prime. How many values of p are there? And question number 7, a plus 2 and a plus 4 are again prime numbers. Then how many values are there? Now first this question was asked in CAT 2, not CAT IIM Kolkata paper for their program PGDCM in 2000. And the same question was asked in 2003 with just a little bit tweak here. Okay. And same thing happened for question number 8 and 9. So 8 was asked in this, you can see number of integers in this range such that n minus 1 factorial is not divisible by n. And then question number 9, number of factorial in the range 12 to 40 such that this product, which is basically n minus 1 factorial, is not divisible by n. So there is a similarity between 6 and 7 as well as 8 and 9. Only the values has been changed. So first this question was asked in the IIM Kolkata paper for their program Postgraduate Diploma in Computer Management. And then exactly the same question was asked in CAT 2003. So anyone who was preparing for CAT in 2003, if that person has already solved this past question of these papers, so that person has an advantage over this. And even today also in CAT you can see a lot of questions they are actually repeating from the previous years or the similar kind of the concept. So it's advisable to all of you that make sure that you are solving all the CAT questions which was asked here. Not only CAT, also the XAT and other papers. Okay, so I'm giving you all around 7 to 8 minutes to solve these four questions. So you can take your time, try to solve these questions. These are not a very difficult question, easy questions. I'll say easy to medium. Of course, when it was asked for the first time in 2000, 2001 or 2003, at that point of time, not many people are aware of these concepts. So that might be difficult at that point of time. But now today, it is a very easy one. So pause the video for next 7 to 8 minutes and then solve it. Okay, so now let's start here. So the first question, that is question number 6. It says the number of choices of a prime number p such that p plus 10 and p plus 14 are also prime. So all these three numbers are prime. So what should be the correct approach here? So instead of doing any guesswork, you should know what is the correct approach. So there are three numbers. That is, first number is p and this number is nothing but that number is a prime. Okay. Similarly, we also know that the value of p plus 10, this number is also a prime number. Okay, and p plus 14 is also a prime number. And here we are supposed to find out how many values of p are there. So let's start with 2. So if I take p is equal to 2, which is a prime number. So 2 plus 10, that is here, 2 plus 10, it is equal to 12. So is 12 a prime number? No, 12 is not a prime number. So this case is not possible. I do not need to check for p plus 14 because all the three numbers should be prime. So here p plus 10 is not prime. So it means this case is not possible at all. Now after that, take next prime number, which is 3. So 3 plus 10, next p plus 10 is 3 plus 10, which is equal to 13. Is it a prime? Yes, it's a prime number. Then p plus 14, that is 3 plus 14 is equal to 17. Is it a prime? Yes, this is number. So this is satisfying. So this is my possible solutions. I can say this case is satisfying here. All right, and let me highlight this, that this case is satisfying. But then after 2, 3, then the next prime number is 5, then 7, then 11, and then 13. Okay, I can keep on counting here, but there are infinite prime numbers. How many prime numbers exist? We don't know. We have no idea. So it will become a very difficult thing. And that's why one of the options is infinity also. So what we can do here, we know one fact that every prime number, it is in the form of 6k plus minus 1, except 2 and 3. So except 2 and 3, all the prime number can be represented in the form of 6k plus minus 1. So after 2 and 3, let's say if my prime number is in the form of 6k plus 1. Okay. So 6k plus 1, so p plus 10 is nothing but that is equal to 6k plus 1 plus 10 here. And this is equal to nothing but that is 6k plus 11, which I can say that is equal to 6k plus 12 minus 1. And 6k plus 12, if you take out 6, so this is equal to nothing, 6 into k plus 1 minus 1. Or it is in the form of, I can say, let's say 6a minus 1. So 6a minus 1, so it may be prime. It may be prime. Depending upon the value, it may be prime here. Or you could have also done in this way, that since 6k plus 1, let me highlight this, 6k plus 11, since we are not able to take out anything common, so it means it can be prime. So it may be prime. Okay. Now similarly, now I need to find out p plus 14. So let's take p plus 14 now. So if I take p plus 14, so 6k plus 1 and plus 14, so that will be equal to 6k plus 15. Okay. Now here 6k plus 15. So in this case you can take out 3 as common. So this is 3 into 2k plus 5. Now 3 into 2k plus 5. So it is a multiple of 3. Yes or no? It is a multiple of 3. So it is a multiple of 3. So can it be prime? No. Because prime number is only divisible by the number itself and 1. Since it is a multiple of 3, so this number can't be a multiply. Like 3 into 2, 6, 3 into 3, 9, 3 into 4, 12. These are all composite numbers. So it is not a prime. So is this case valid? No. Because the condition is all the 3 numbers should be prime. So first 2 can be prime, but the third is definitely not a prime. So this case is also ruled out. Now, after that, the other prime numbers are in the form of what? 6k minus 1. Alright. So if it is in the form of 6k minus 1, so I can take the number of the form, let's say 6k minus 1 here. Let me write down at the bottom here. So this is 6k minus 1. So 6k minus 1, so p plus 10, that is 6k minus 1 plus 10. And that will be equal to 6k plus 9. Now again it is a multiple of 3. You can take out 3 as common. So that will be equal to 2k plus 3. And since it is a multiple of 3, so it is not a prime. So since it is not a prime, so we do not need to check plus p for p plus 14. Because all the 3 subs should be prime. If one of the number is not prime, so we can rule out that case. So this is also not possible. So how many solutions are there? You can see only the number 3, only the value of p equal to 3 satisfying. So there is exactly one case here. So the correct answer for this question is nothing but option number B. And this is the only case. The numbers are 3, 13 and 17. So these are the only 3 numbers which are satisfying this condition here. So I hope that this is clear. So an easy concept, and in fact in CAT you can find out a lot of questions related with the prime number properties here. Now let's come to question number 7. So if you have solved question number 6, if you understand the concept of question number 6, try to solve this question on your own. Again pause the video, try to solve it. I'm sure that you can find out the answer. Okay. If not, now check the videos again, but the similar concept. So I can say the condition here is that a plus 2 and a plus 4, all the 3 numbers are prime. So I'll take first of all a equal to 2. So 2 plus 2 is 4. Okay, I can say that is 2 plus 2 is 4. Here basically this is 2 plus 2 which is equal to 4. But 4 is not a prime number. So we can rule out this case. Not possible. After 2, next prime number is 3. So 3 plus 2. So 3 plus 2 that is equal to 5. And 3 plus 4 which is equal to 7. So here all the 3 numbers are prime. 3a is prime which is equal to 3. A plus 2 equal to 5 which is also prime. 3 plus 4 7 is also prime. So this is satisfying. Here we are getting all the 3 numbers as prime. Now after 2 and 3 all the prime numbers are in the form of 6k plus minus 1. So if a is in the form of 6k plus 1, then a plus 2 that is 6k plus 1 plus 2. This is equal to nothing but that is equal to 6k plus 3. And you can take out 3 as common, so into 2k plus 1. So a plus 2 is a multiple of 3. So if it is a multiple of 3, definitely it can't be a prime. So this case is not satisfying. So I do not need to check a plus 4. So this case is also ruled out. Third case, or in fact fourth case and last case. If a is in the form of 6k minus 1, then what is a plus 2? A plus 2 will be equal to nothing but 6k minus 1 plus 2, which is 6k plus 1. Now, since it is 6k plus 1, so it may be prime. It may be prime. So, let's check for a plus 4. So, for a plus 4, that is 6k minus 1. That is the value of a and plus 4. So I'm getting this as equal to nothing but that is 6k plus 3. Again 6k plus 3, 3 is common, so this is 2k plus 1. And it's a multiple of 3. So if it is a multiple of 3, it can't be a prime. So this case is also ruled out. So how many solutions are there? There is only one. There is a unique solution. So 3, 5, 7. So the answer is option A, which is 1. But yes, the answer, like one of the option choices more than 3, that is also possible depending upon the values here. But the values are given in such a way that in both question number 6 and 7, we are getting a unique answer. So I hope that this is clear to all of you. Now, let's move to the next question. That is question number 8 and 9. Again, it is based on the properties of prime number, both 8 and 9. But first, it was asked in postgraduate diploma in computers management paper, and then it was asked in CAT. Okay. So the question number 8 says the number of positive integers n in this range such that n minus 1 factorial is not divisible by n. Now there is one theorem, but even if you do not know that particular theorem, you can solve this question. So I'm not going to discuss that theorem. Alright. So let's see here. If I'm not from the maths background, then what should be my approach? How to solve this question? That is more important. CAT doesn't expect you to know all those fancy theorem like Wilson, Chinese remainder theorem and Fermat theorem, and there are so many other theorems. No, that is not needed for cracking CAT. Now, so it says number of positive integers n such that n minus 1 factorial. So I'll say, let's say n, and this is n minus 1 factorial. Okay. And n is starting from 3. So I put n is equal to 3. So what is n minus 1 factorial? N minus 1 is equal to 2 factorial. So that is equal to 2. So 2 is not divisible by 3. The question is that n minus 1 factorial is not divisible by 3. So it is not divisible by, I'll write down not divisible by n. So 2 is not divisible by 3. Yes, that's a correct one. 2 is definitely not divisible by 3. Let's start with n equal to 4. So if I take n equal to 4, so I'll get 4 minus 1, that is 3 factorial. 3 factorial is equal to nothing but 3 into 2 into 1. And it says that it is not divisible by 4. Yes, that's right. 3 factorial is equal to 6. Is 6 divisible by 4? No. So here n equal to 4 is satisfying. After that, I'll take n equal to 5. So this is factorial 5. So factorial 5, not factorial 5, but rather it is factorial 4. Alright. So I can say, let's say this is equal to factorial 4. So factorial 4 means what? That is 4 into 3 into 2 into 1. Now, is the product divisible by 5? No. Reason being, why it is not divisible by 5? That it says it is divisible by 5? No. It is definitely not divisible by 5. Okay. So it is not divisible by 5 here. Okay. I had put a wrong sign here. Alright. So yes. So I can say basically n equal to 4 is also satisfying, n equal to 5 is also satisfying. All of them are true. All these statements are true. All these 3 statements which is presently on the screen here. So 4 into 3 into 2 into 1 is not divisible by 5. In fact, all the prime number will satisfy this condition. Why? Because prime number is only divisible by the number itself. So if I say, let's say after 5, if I take, let's say the next prime number, that is 7, just for an example. So I'll get 6 factorial. So I'll say this is 6 into 5 into 4 into 3 into 2 into 1. So is it number divisible by 7? Definitely no. So this is also satisfying that this number is not divisible by 7. Why? Because the smallest number which is divisible by 7 is 7. So product of any number which is less than 7 is never a multiple of 7. And it is going to be true for all the prime numbers. Like if I take a next prime number which is going to be 11. So I'll get 10 factorial. So 10 factorial, if you write down the product of first 10 natural number, is there any number which is a multiple of 11? No. For the first time, we are getting a multiple of 11 in 11 itself. So 5 into 4 into 3 into 2 into 1. So you can see none of these numbers 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 are divisible by prime number 11. Okay. Similarly, 13 will not satisfy because any number which is a multiple of 13, the smallest number which is a multiple of 13 is 13. But when I put here 13, I'll get 12 factorial and it is a product of first 12 natural number. So among the first 12 natural number, none of the number is divisible by 13. So that's why this is also satisfying. So we definitely need to count all prime numbers. So all prime numbers are definitely satisfying this condition. Okay. Now if I take a composite number, now we have seen that one of the composite number, that is 4, is also satisfying. Okay, let me highlight this 4. Okay, 4 is also satisfying. So this is one composite number is satisfying. What about the other composite number? Let's see here. If I take a value 6, okay, if I say let's take a number 6 here. 6. Remember, composite number is made up with the help of a prime number. So 6 means I'll get 5 factorial. So 5 factorial means what? The 5 factorial, I can say this is 5 into 4 into 3 into 2 into 1. But 6 is 3 into 2. So if you multiply these two numbers, that is 3 into 2, that is equal to 6. So in that case, you can say that it is a multiple of 6. So after 4 onwards, every composite number will not satisfy this condition, because 6 is a product of 2 into 3. And when you write down the product of the numbers which are lesser than 6, then you can get one combination. Like here 2 into 3, which is a 6 here. Let's take for example 8. Alright. So if I take a number 8, so I'll get 7 factorial. So that is 7 into 6 into 5 into 4 into 3 into 2 into 1. But here again, if you look at here, can you say this 4 into 2, which is equal to 8? So this product is divisible by 8. So it is also not satisfying, because here 7 factorial is divisible by 8. So from here onwards, if you take any prime number, remember, sorry, any composite number, all the composite number are made up with the help of a prime numbers, a smaller prime number. So with the help of those smaller numbers, we can form that number, like 9. So 9 is equal to product. 9 means what? 8 factorial is not divisible by 9. That is a false statement, because 8 factorial is 8 into 7 into 6 into 5 into 4 into 3 and so on. If you multiply these numbers, then it is divisible by 9. So the important thing here is that we can say all prime number and 4 is also satisfying. There is only one composite number which is satisfying this condition, and that composite number is 4. So that's a very, very important thing here. So if I can write down, or you can also note it down, okay, if there is a statement like this one, that n minus 1 factorial. So n minus 1 factorial is not divisible by n. Okay, is not divisible by n. Not divisible by n. Then what are the values of n? N is nothing but that is all prime numbers. Okay, all prime numbers and one composite number, that is 4. That is the only exception here. So that you need to remember here. So even if you are doing this one, even if you are doing for the first time, probably you can count all the numbers quite easily here. So now what I can say here is, what is the correct answer? Just count how many numbers are there in this particular range. Okay, how many prime numbers, and 4 also I need to check here. So from 2 to 20, I'll count the number, that is 3 is satisfying. Okay, then 3, 5 is there. Alright, so 3 is satisfying, 5 is there, then 7 is there, 8, 9, 10, 11 is there, then after 11, 13 is there, then 14, 15, 16, 17 is there, and 19 is there. And in addition to this, I need to include one more number. This is where people forget, that number is 4 also. So how many numbers are there? If you count how many numbers are there, how many numbers? I can say 1, 2, 3, 4, 5, 6, 7 and 8. So the correct answer for this question is option C, which is equal to 8. Alright. Okay, so I hope that this is clear to all of you. Now, let's move to question number 9. Same question. Okay, the number of positive integers n in the range is now from 12 to 40. There is an equality sign, so that you need to be careful, such that the product, this product, so this product is actually what? It is nothing but, it represents n minus 1 factorial. Okay, it represents n minus 1 factorial, is not divisible by n. So we know that 4, but whether 4 is satisfying, the composite number 4 is lying in this range? No. So I just need to simply count all the prime numbers in this range, because one composite number is satisfy these conditions, that 4 and 4 is not lying within the range. So how many prime numbers are in this range? Just count it here. So I can say that is 13. Alright, then 13, 14, 15, 16, 17. Then I can say 19. Then it is 23. And then After 23, I can say 29. Then it is equal to 31, 32, 33, 34, 35, 36, 37, 38, 39. No, that is. So these are the numbers which are satisfying. Okay, 13, 17, 19, 23, 29, 31, 37. So how many of these numbers are satisfying? Exactly 7 numbers are satisfying here. Okay, there are the 7 prime numbers within this range here. Alright, so the correct answer for this question is nothing, but that will be comes out to be how much? That is 7. So I can mark the answer as 7. That is option number B. So I hope that it is clear to all of you. Okay, again my advice, please go through all the past year papers. That is very, very important. Okay, sometimes the question repeats. Even last year also couple of questions has been repeated from these postgraduate diploma in computers management program paper. Okay, there were 2 to 3 questions. All right, so now all right, so that's all for today. And we are also conducting a lot of free webinar, so you can find out the information regarding those free webinar on the description section below this video, where I have posted the link of the Telegram group and the WhatsApp group. So you can get all the information on these groups here whenever we conduct all these free webinars, and the link for these free webinars. So thank you.